Welcome back. Now, based on the concepts which we learned in our earlier videos, let's do this problem. Okay, here is a plasma concentration time points. The very first step is to find the beta phase beta slope, right? So the equation for any slope is a difference on y-axis or difference on x-axis. That's what we know. And the equation for the beta slope, since it is a natural log, we're going to apply a natural log for the concentrations. Here I'm taking 4 plasma concentration time points because that is a minimum number of points that are required to solve for a pK parameters for a 2-compartment model, right? So here I selected 28 and 0.52 plasma concentration at corresponding time points of 8 and 12 hours here. So let's plug into this equation. Ln of CP2, that is 0.52, minus ln of CP1, that is 2.8, divided by 16 minus 8. Okay, here. So if you solve for this equation, 0.211 over hour, that is hour inverse, by the way. Okay, the next step is to find out the intercept for the beta phase, guys. So you know the equation for the 1-compartment model. Since this looks like a 1-compartment model, if you extrapolate it, so we can use this equation, right? But let's rephrase this equation in a different way for our convenience. Since Cp0, okay, we are calling it as B, so we'll call it as Cp is equal to B times e to the power of minus. Since the elimination rate constant, we are calling it a beta phase and beta. We'll plug it, and time is t, as usual. So what is B here? We don't know. That's what we are going to find out, but we know Cp, right? Let's take this point 2.8 at a time point of 8 hours. So 2.8, what is B here? We can find out. E to the power of minus beta is 0.21 times the time is what? 8 hours, right? So this is the time point which we are taking. If you solve for this equation, then you'll get a value of, for the B is approximately 15.08 microgram per ml, because that's the units, right? Microgram per ml over here. Okay, now that we know the beta intercept, now the next thing is we have to find out the extrapolated points, the Cp extrapolated for the corresponding time points of the actual plasma concentration. So 43 microgram per ml at a 0.25 hour. So we're going to find out Cp extrapolated at 0.25 and 1 hour. Let's find out that. So Cp extrapolated at, let's say this is 1, is equal to B, we know just now we figured out 15.08, okay, times e to the power of minus 0.21 times, okay, at what time point? 0.525, right? If you solve for this one, you'll get a value for a Cp extrapolated 14.3 at 0.25 hour. Similarly, if you solve for a Cp extrapolated 2, that is a plasma concentration at 1 hour, let's do that. 15.08 times e to the power of minus 0.21 times 1 hour. If you solve for this one, you'll get a value of 12.22. okay, now we get a value of how much? 12.22 for this one at 1 hour, right? And 14.3. okay, if you subtract between the actual plasma concentration and the extrapolated plasma concentration, we will get a value of 28.7 and 7.78. okay, using these two values, again we can find the slope for this residual line. Okay, let's do that. Okay, the equations are same, guys, but the notations will change. Instead of beta, we'll call it alpha. Instead of Cp2, let's call it Cp2 extrapolated and Cp2 extrapolated 1. Now that we know the residual values, we can calculate the residual slope, okay, using this 28.7 and 7.78. let's do that calculation. So ln of 28.7 minus ln of 7.78, okay, divided by the time point, it's 0.5 minus 1, okay, then alpha, the slope for this is 1.74. The units are 1 over hour, or we can call it as hour inverse. Either one is same. Now that we have alpha slope, can we calculate the alpha slope intercept? Yes. Same equation. Cp is equal to Cp naught into e to the power of minus kt. But here Cp residual, and Cp naught is we call it A times e to the power of minus, instead of k we will call it alpha times t. Let's do that. Cp residual, let's take the value of Cp residual 28.7. okay, Cp residual 28.7 is equal to A. That's what we are trying to figure out. A times e to the power of minus alpha is how much? 1.74. Just now we calculated, right? 1.74 times the corresponding time point for the concentration of Cp residual is 28.7 is 0.25. If you solve for this one, you'll get a value for A. It is 44.3. We'll do one more and we'll wrap it up for this video. Okay, let's find out the Cp naught. Okay, Cp naught is what? A plus B, right? The value of A intercept plus B intercept is how much? It's 44.3 plus the B intercept is 15.08. We'll get a value of 59.04 if you solve for this one. 59.04 microgram per ml. Okay, I'm going to stop this. We're going to continue in the next video.